Thank you all for coming here. I know it's many things happening now. First of all, it's Friday. There's the hackathon results thing going on. There's Tableau thing going on, and still you are so many. So happy to see you here. My presentation is about Finns using FME like crazy, and this presentation will be quite crazy as well. It's 47 slides, so I'm going to fly through them very quick. Maybe this much time for questions, or I'm not trying to teach you any technical nice tricks because I couldn't anyways. So it's more like giving ideas what you can do and what has been done by our Finnish customers. So first, shortly about me. I'm Managing Director of Spatialworld Oy. As you can see, this long name, Hannu-Pekka Rantaniemi. Everyone knows me in short by HP. Much easier, right? Master of Science in Civil Engineering. I had geodesy and photogrammetry as my main areas. I used the System 9, 93 and 95. Who has heard about System 9 before? One, good. So I was expert then for that. Then I started with Smallworld 95. I had my first FME tryout at 98. Still trying it out, not really doing much with it. The other guys are doing all the work. I have a wife, 3 adult kids. My youngest will turn 20 today. So happy birthday, Antti. I have 2 cats. I had 2 weeks ago, I had 3, so I had to edit this. There's now only 2. My hobbies, you can see the pictures up there. Running is one. The picture there is right after finishing Berlin Marathon some years ago. Then is my sort of safe software FME advertising tour on the Finnish archipelago using my Canadian-made canoe, yes. And then there's me having some fun, and then skiing. So I'm quite a bit of outdoor person, but I want to have fun as well. Then about the company, it was started in '94 with the name of Smallworld Systems AB. So we were a Smallworld company fully. Then we became even more Smallworld company because we were merged with the whole Smallworld and went to Nasdaq. GE bought the whole thing from Nasdaq 2000, and 2002 we bought ourselves out from GE, which was a good day, very great day. And we were celebrating that a couple of years later. In the beginning of 2004, we signed an agreement to be officially FME resellers. We did something before that as well. We have customers in Finland, Estonia, and Russia. We run help desk, provide training, consultation, and just a little bit of development. And here, that's sort of our customer base, not maybe each single one, but here, rough summary, 94 customers in total, 74 active ones. In Finland, there are some who are not using FME anymore, so I don't call them, or they might use, but they are not paying at least maintenance, so to me, that's not an active customer. And I was really surprised to count that we had 21 customers who are using FME server already. Before counting, I thought it would be something like 13 or 15, but really 21. So I'm happy for that. So in the presentation, I have some examples how the Finnish customers are using FME in a creative way, not the basic format to format and that kind of stuff, but a little bit special ways. There's, for example, business intelligence, quite a bit, reporting, quality assurance, and using FME to visualize data in ClickView and Tableau. And we have from Caruna in Finland, Arto Matsinen in here. So here are the examples. So Caruna is there in the middle, and that's the first one I'm going to talk about. I will have a little bit of from all of these different customers. And a little something that we have done, or Lassi Tani, who someone might know, has done. So Caruna had a need to inspect network data documentation to check that users are producing data as it should be produced. So you are filling all the attribute values as should, and things are connecting and so on. And then also to give feedback and report it in a nice and what's important, automatic way. So if you have any questions after the presentation, you can talk with Arto. His team has been doing this stuff, and he has been doing this stuff. So a little slide with a bit more text. So network data inspection tool is meant to be used as a helping tool for Caruna and third-party employees to working for Caruna to ensure that the content of data is as it should be. It's been implemented on FME server Oracle database environment, and they have added in the network inventory system a button. I think it's more or less a button just there, which you can run, and then it's running the checks. A few of those, 265 rules built and used. One rule can inspect several object classes and different data fields, so it's not just that you have one rule for one thing, but one can be used for many. Of course, checking the network connectivity, and there's no limit how much you can expand it. You can do things with SQL, PL, SQL, Java, and of course with FME. Basic limitation is that how your skills are, and that's it. And it's even protecting the master database. If you are doing something very stupid, it doesn't let you update the data. So that's quite clever. So FME server read and prepare data and then write that to XML files for ClickView, where the report visualization is done. Only some ratio values are calculated on Click side. Everything else is on FME side. And database is not read directly to uncertainly working ODBC links during long-lasting queries. So if there is a break, it fails. So not done directly. Then also Tableau is used. There are some example pictures of both. Their data is read directly from the database using FME server and then written into TDE files. And here again, calculations including some values are all done on FME side, even if you could do those on Tableau side. But it's better that where you have the data, you process it and then you pass as little information further on if you need to. No need to pull all the data or push all the data ahead. Yes, and all these processes run automatically daily. Here, example of documentation quality, key performance indicator. You can see here that's sort of the inspected, all the inspected objects, and the amount of how many of these objects had some problems. Then the same as a pie chart, and then the same based on different areas, network areas. So you can see what's the quality, and you might think that it's like 95.8 or whatever, that okay, so that means there's some 4% of erroneous data. Might seem that it's a lot, but it's not. But then the thing is that now you know how much you have and where. And that was sort of the year. Where's the mouse? Here. That was the sort of a floating year, and then there's the month, which is happening right now, the same thing. So here you can see that there's slight improvement. So you are going to the right direction. This month has been better than the last sort of floating year. And then errors per object and error type. Here on this one, you can see the amount of errors per object type. And then next to that one, you can see the errors by type. So if I can read it, there are structure problems. There are problems with the technical information, and there are problems with age. So those are the most typical problems that there are. And then here in the bottom, you can see there's a project number, inspected items, objects, then the amount of objects with error, and so on. So this is all fresh data, automatically generated every night. And then documentation quality history. So here you can see, is this Arto more or less all the time this has been running?
Yep, we started to use that at July of 2016.
Yeah. So you can see it's been useful. There has been improvement here. The quality is getting better. And here again you can see the under here you can see how the quality is developing per sort of network area. So there's been one like in here where the quality has been good already from the beginning. So that's also nice to know. But on the other hand, you can see the curve is going up, so that's good. And then example of Tableau, so you can see how many times this analysis have been run, how many objects were involved, how many errors there's been, and how many objects with errors. So of course one object can have several errors. And interestingly as well, this is how long the operation runs in milliseconds. So if it will visualize immediately if something is taking a long time, so then Arto and his team can grab into it and make it better. But now this is milliseconds, so it's not really, nothing is really taking time. Then another case, customer who is really in love with the FME. So City of Vantaa is often trying to first think how to solve problems with FME. And often they also build the solution using FME in the end. Or they at least build a pilot. So this is their own presentation from our user conference recently. So this is how much in love they are with FME. And it just gets better. So you will not get this anatomic heart. I was forbidden to give that version of this. Someone might have some rights for this, but I'm okay to show it to you. So here's some examples. They are using a lot of relational database, Excel, and then sort of a cloud data, APIs, and they just simply automate all kinds of processes. They do quality control for all the data, of course, always before when they're analyzing it, the quality control should be in the beginning always, I feel. They are using a lot of open data as well. They publish open data and they use open data. And they are, basically the main thing here is that they have been building situation awareness with map visualization for interesting things. Like here, this is the health center queuing time per health center. So when it's red, of course, then that's bad, too long. So this is good information, but then they want to know why as well. Why does it take so long? So they are checking the patients, where do they live? And then they put them on the map. And when they were matching these two, they saw that, okay, they should do something with the sort of areas per health center, because people are not coming from the right spots, or they are a little bit far away as well, or too many for a certain health center. Then another interesting for IT people, they have been visualizing IT problems. So this is how you can see where the IT problems are. If there's a printer problem, network problem, machine problem, whatever, it's visualized. And of course, if it's not solved, it's red, and so on. Another great idea. Then using open data from cloud, the Finnish traffic cameras are available as open data through an interface. And City of Vantaa is taking all of that and putting those on their own maps so that it's easier for the people to find, because not everyone knows how to find those from the open data. No, it's not sort of every person's skill. Then another interesting one, City of Helsinki has made 2 different 3D data models for the entire city. And those went live in the end of last year, December. They have intelligent semantic city data model and visually very high quality triangular mesh model, both done and released at the same time as an open data. And Helsinki is globally the first one to do both of these. So the semantic city GML data model, that's on LOD2 level. It could be more, but to get it out and so on, they decided to do it on this level, which is already quite nice, reasonable, but not huge amount of information. So those can be used for different analyses, and you can enrich that, put more and more data, and what's important, they have planned a continuous updating procedure for this. So it's not just that they make a model, but they're actually maintaining it, so, which is important. And that's the first one in the Nordic countries. There are other ones made in Germany and the Netherlands. And did I hear in the beginning of the week also in Singapore or somewhere. So quite new. And then the 3D triangular mesh model was made from aerial photographs. Main benefit for that is that it's really, really realistic. Even small buildings, trees, cars, human beings, whatever that was there, it's in the model. And this, I think there's no limitation on using this from abroad. So there are links. So you can go there and fly around Helsinki and look how it looks. And of course they are going to do Minecraft Helsinki for gaming as well, but like the city of Vantaa did that already a long time ago. So, but here visualization of the semantic model, and then here the 3D triangular mesh model. As you can see, it's really accurate. And if you go to the web page, you can zoom in and so on and see that it really works. So this is the environment. I'm not going in great detail in here, but there's an FME server lying in the middle, waiting for someone to ask for something and then going and fetching it. Here a little bit more in detail what's happening. So everyone can go there and ask for the data. You can define an area. I want buildings and whatever from this area. I want them to be on this format. And using this and this LOD level, okay, you have only LOD2, so if you ask for better, you don't get because it's not there. But anyways, it's ready for that. So you can take buildings, vegetation, roads, so on. You can define different texture classes, and so on. And you get the data as a link. So you're not going there to ask for the whole Helsinki city model, but you can go to a certain area and get some chunk of data. And here's the mandatory workspace for my presentation. Not going through every transformer by transformer, you know, and that's it, done. And next customer, Suppershape. They actually gave a presentation 3 years ago in Vancouver already. So this is partly the same things, but they have done more. They have developed all kinds of UAV solutions for data capture, data analysis, and here are some examples what they have done. For example, they use FME to plan the 3D, in 3D the flight route, using the terrain model, vegetation information, obstacles, if there are some, and network inventory system route information, because they are flying automatically over the power lines. So, and then once they have done that, when they are doing the fly out, they capture, they do laser scanning, they are taking very high resolution pictures, videos, all that stuff. And FME is used to analyze that or to clip it. For example, for point cloud, they clip that area that they are interested. For example, a pole location. They don't want to use the whole bunch of the data. They want just as little as possible So they are cutting that with FME. And FME is used for automatic pattern recognition from pictures, and it's amazing how fast it is. I didn't believe when they told me what they are doing, and they said, "Hey, really?" And on his laptop, he could run it. Some amazing analysis, takes us a few minutes. And their goal is to develop fully automatic UAV inspection routine. So they come somewhere, they have all the data there ready for them. They press a button, and everything could happen automatically if it's illegal on that country. And sort of out of sight flying as well. They have permission for out of sight flying in Finland, the only one, or at least the first one. So this one thing they do, this they call it akka vegetation management, so automatic corridor clearance analysis. If anyone is from power company, you know what it's needed for that, so it's quite a lot of work and money involved. So they want to find the problematic trees which are about to fall on the power lines now, or maybe you can do prediction as well. They are actually identifying tree by tree. So they know how those grow, and then they can say, okay, you need to cut this after 3 years, 10 years. So you get a ready plan for vegetation management. Automatic pole detection sort of feels quite easy. Then a little bit more complicated, automatic corrosion detection. So what's in red in here, that's corrosion. Actually what's in blue, that's another thing which is highlighted in here. So there's automatic insulated detection and problem finding. So when the drones are also sending the information while they are flying. So that's one thing. Everything is in cloud for them. And they can do this analysis more or less immediately. And here you can see that there's a problem with this one. It's red. Red is good for problem. And there's one insulator plate is broken in here. That's missing. So there's a problem. And that's found automatically. From the ground would be really hard to find that. But they are flying very close to the power lines and very high resolution pictures, so that's why they can do this. Then university, Tampere University of Technology, there, the Department of Architecture, they have done a bit of different data visualizations. Here's the traditional one. What they have done is that they have taken, there was a survey for office building, how people felt about that. And they combined the CAD file, so BIM model of the building, and this Excel with the results, and made this 3D PDF out of it. As you can see here, it's almost everything on this workspace is related to visualization, architects, okay, important thing, and then 5% is sort of doing the trick. Then they have done the same with the human being. So they were not measuring the rooms and the queries in there. They are measuring the human being working in a room. So they're using a human model. And so the same thing, combining the data and visualizing it. For some reason, we didn't get them a visualized person. Maybe that was too personal for someone. Then another one, only one slide from this one, that's the Finnish Transport Agency, and they publish data maintenance process as open data. This is a good one, as you can see here that they are using FME heavily. They are using it in the sort of back office. They are manipulating data for all the different systems in the back office. Then they are using FME server to publish that to a database, Oracle database. And again, they are using FME server to get the data for people out from there. Bontra Energy is a very new customer, less than a year old customer. They haven't used FME at all for spatial data so far. They've been using CSV, Excel databases, and they just did or are finalizing customer information system conversion with it. Who has been involved on conversions? Quite many. So you know all the problems. The target and source systems, they are different data models. Basically, they are very, very different. And there's a lot of data involved. You hope only some of the data is not structured, but often it's a lot of the data is not really structured. It can be free text, summary incoherent, so people are using different terminology, so on, if the system let them do it. So it can be very difficult to understand what's happening there. For example, in customer information system, those people responsible for that, they are business people. They are not GIS people. They are not really data modeling people. So it can be hard to define what and how to move, and definitions may change while they see how the data goes in the new system. When they are doing test conversion, they want to change the definitions. So I'll just go through this very quick. The traditional way is that you have a meeting, you have the old system guys, new system guys, your business people, you define everything. That's fine. That's what you should do always. But then implementation is done using code, SQL scripts, and so on. And when you do it like that, the rules are embedded in code and scripts, and it makes them very tricky, big, complicated, difficult to manage. And if you want to change it, that's a hard thing to do. So they did it in an FME way. To explain this in short is that they used terminology in the original system user interface, and that terminology was put in the files to move the data. And then the same thing on the target system side, and FME is used in between, and even to visualize in the meetings what's happening. So this is the traditional way. There's a lot of little text there, and there's an Excel for the conversion file. And then there's a new FME way. This is simplified, but anyway, when you run this on FME, you can see how many objects are going in, how many are going out, and if the amount drops down for some reason, it can be bug in the definition in FME, but it can be bug in the definition people have done. So you can visualize in a meeting, and then even change it there in the meeting. So FME benefits. As I said, you can see when you are running it that some data is vanishing. Changes are easy to implement on Workbench, even in the meeting. So think about it, business people there, and they like it. They see visually how the data is going. Conversion control is at the customer, as it should be, and potentially huge savings. So we will hear maybe in our next user conference how much they saved. And then just for the fun of it, a couple of things Lassi has done. Very good example of simple two CSV files combined together to generate 4D KML file, which you can show on Google Earth. That's traffic coming in and going out from Helsinki. So you can run it, and it's showing sort of the amount of cars going in and out. And then the last one, with only a few slides, Lassi made for City of Helsinki analysis, reporting, and visualization of that using FME. All the results are PDF files and interactive ones. So here's one, that's cumulative 12-month electricity usage, including customer type. So from the area, you see the total amount, and then from the pie chart, you can see how much energy is used for different purposes. And then you click on it, and you can find more information. Then another example, long-term yearly trend of electricity usage, including customer type. So here you can see sort of the total amount, and then all these are different customer types. For example, if there's construction happening somewhere, it's using energy for certain time, but not for long term. And then change detection and visualization, you can see that how much less or more they have been using, and who is the one, or which are the business areas using it. And I think this is the most important slide. That's all the other ones were just for this one. So key takeaway, keep your mind open. FME can be used for almost anything with data and process. So you can read the data, you can manipulate, you can combine it, and you can build an automatic process. Okay, thank you.
We're almost at the end of our time, but does anyone have a quick question for HP?
As I said, you should ask for the Caruna things from Arto, and the last bits from Lassi. Don't ask me anything. Just buy me a beer. Just buy me a beer, and I am happy. Thank you.